Hello, I'm Laura Marshall.
And I'm Melinda Rose, and this is Light Matters for March 6, 2013.
On this week's show, the U.S. science community braces for budget cuts under the sequester. The outlook is bright for UK manufacturing. A landmark research investment in Ireland includes photonics. The uncertainty principle has some uncertainty of its own. And the world's largest fiber optic network is underway at Sandia National Lab.
Now that the $85 billion in across-the-board government spending cuts have taken effect under the sequester, the U.S. science community is bracing for impact. The National Institutes of Health will lose $1.6 billion, or roughly 5% of its appropriation this year. The Institute estimates that will mean 2,300 grants that it planned to fund will not be awarded. Appropriations to the National Science Foundation will also be cut by 5%, or about $375 million. Last week, the foundation said that it will reduce the grants it awards by 1,000. Senior research officials at the Department of Defense estimate that DoD funding for university research will be cut by about $300 million this year.
Meanwhile, the outlook for research and manufacturing is bright in Europe, where two large investments were announced last week. The UK Engineering and Physical Sciences Research Council announced that about $18 million in grants will support 4 new research centers to improve manufacturing. One of those is the project The Light Controlled Factory, headed by the University of Bath, which seeks to develop and use novel lasers and optical methods for both the accurate measurement of large and complex products and the real-time control of machines within a future factory. Also, the largest ever state industry co-funded scientific research investment was announced in Ireland last week. The $393 million investment from Science Foundation Ireland and industry partners includes millions to establish a large-scale research center devoted to advancing photonics and biomedical science, one of 7 new research centers that will support more than 800 scientists. The goals of the Irish Photonic Integration Research Center include taking photonics into new application areas, such as point-of-care diagnostics and minimally invasive patient monitoring and screening.
Heisenberg's uncertainty principle says precise measurements in the quantum world are impossible, but a method developed at the universities of Rochester and Ottawa directly measures the polarization states of light for the first time, something thought impossible on the basis that you could never fully understand a quantum system through direct observation. A team led by Robert Boyd discovered that it is possible to measure fundamental related variables, known as conjugate variables, of a quantum particle or state directly by using 2 crystals of differing thicknesses. Being able to directly measure quantum states is important for quantum information science. Quantum tomography previously has allowed indirect measurement, but was a time-consuming and data-intensive process. The work was published in Nature Photonics.
Sandia National Lab is constructing the largest fiber optic local area network in the world. The network, which began moving to desktops in 2011, pulls together 265 buildings and 13,000 computer network ports and brings high-speed communications to some of the lab's most remote technical areas for the first time. It will save an estimated $20 million over 5 years through energy and other savings and decrease the need for replacement equipment. Sandia, which will spend about $15 million on the project, needs superb computing capability as part of its support of the National Nuclear Security Administration.
Just a quick reminder that seats are still available for our webinar on techniques in biophotonic imaging, which will take place Thursday, March 21st at 1 p.m. Eastern Time. Speakers include Dr. Kamani Toussaint of the University of Illinois, Dr. Melissa Scala of Vanderbilt University, and Dr. Ofer Levy of the University of Toronto.
You can register for the webinar by clicking the link in this show or visiting photonics.com.
And that's it for this edition of Light Matters, Photonics Media's weekly newscast.
As always, you can write to us with your comments, suggestions, or questions at lightmatters@photonics.com.
Thanks for watching, and we'll see you next week.
When people ask me what I do for a living, I tell them that I analyze rainbows, because when you take visible light and disperse it with a spectrograph, it literally makes a rainbow. And if you turn the lights out and put a business card at the focal plane of the spectrograph, you'll actually see the rainbow. And I've taken pictures of it and posted it on my Facebook page so people can see what it is I do. And then when they ask further, we analyze the rainbows to make the world a better place. We analyze rainbows to help cure cancer, to help make food safe, to analyze materials, drugs, and things like that. And if you put it that way, people seem to get a clue about what it is we actually do. Another way I explain to people what we do is we help people learn more from their photons, which is maybe more appropriate for Photonics West. But anyway, so that's what I say to people.